Hello, I'm Devashish. I'm going to speak about machine learning on source code. All my slides are referred from ML on source code by Francesc Campoy and team. They work at Sourced and the link to their work is in the description. I'm going to cover what ML on source code means, how can we analyze source code, what can be predicted from the source code, and how useful this will be for the future. Machine learning on source code is very simple to understand. It means applying machine learning algorithms where the input data is the source code. For example, we get the data from GitHub and apply algorithms to analyze or predict the bugs or trends. One of the related fields to this is data mining. That is, getting data, cleaning it, pre-processing it, and making sense out of it. Another related field is natural language processing or NLP. In languages like English, we have syntax, that is grammar, and we have tokens, that are the words. Similarly, here we also have syntax and tokens. The main difference between NLP and ML on source code is that here we need the syntax and tokens to be 100% correct for the code to compile. And in NLP, if the syntax or the grammar is not 100% correct, then also the sentence would make sense. Another related field is graph-based ML. Since the code follows a flow of control, it is quite similar to graph-based ML. Now, what is required for this? It requires lots of data, really lots of data, fancy machine learning algorithms, and of course, a little bit of luck. So what is source code? Source code is a text listing of commands to be compiled or assembled into an executable computer program. A code can be translated into bytes, that is, generating bytes for all the text. For example, package main P in package can be translated into 112, A to 97, and so on. Tokens can also be extracted from the source code, like extracting package, the modules that are important, the function names, etc. Trees like absolute syntax trees can be generated and control flow graphs can also be created. In order to do so, we first need to classify the language, that is, in what language the code is written. It can be Python, C, Java, Go, or anything. Then we have to parse the program to create absolute syntax tree so that all models can use it no matter what language it is written in. Then we can extract token, for example extracting all the function names from the code, and we can also do history analysis on a code, that is analyzing the bug trends, issues, etc. Now, what can be predicted from the code? So we can predict the next token. We can use neural networks for this. For example, if our code says for I equal to 0, I less than 10, I, and then what should be the next token? It should be I++, and this can be predicted using historical data and neural networks. We can generate code also. We can use recurrent neural networks for this, that is, given n characters, predict the next one. So these are characters in sequence, so we'll read them in sequence and predict the next one. This needs many epochs, but after all the epochs also, the code is not 100% syntactically right, so it won't compile. Next, to predict, we can represent programs with graphs. These use graphs to represent both syntactic and semantic structure of the code. And for this, graph-based deep learning methods are used. For example, if our code has a function which prints hello world, then what should be the name of that function? So this can be predicted. And if a function is telling something about foo and the function name as bar, so we are misusing the function name, so this can also be predicted. The next thing is distributed representation of code, that is, representing snippets of code as continuous distributed vectors. The code can be represented as vectors and then similarities and dissimilarities can be calculated from the code. Now, what can we build from this? We can create an automated attention model for code reviews. That is, a model will automatically notify the user whether the code has errors or not. We don't need to wait for code reviews, we can automate it. We can create automated style guide enforcing, so our model will help the user to do proper indenting, to use proper tokens, and so on. We can create a bug prediction model from this, and we can also do many other things. So now we have learned the basics of machine learning on source code. I would recommend you to go through the description and to the source link on ML on source code. They have explained it very nicely with proper demos. It will help you gain a better understanding. Thank you.